Welcome you all in this most popular non-destructive testing that is called dye penetrant testing or liquid penetrant testing. So what it mean? What do you understand by dye penetrant test? It's commonly used for detect the surface cracks or defects. Whatever defects if a product have on the surface, you can find out by dye penetrant testing. DPT is one of the most widely used NDT methods. In every industry, in every department, you will see dye penetrant testing. Dye penetrant testing can be used to inspect almost any material provided that its surface is not extremely rough. If the surface is not extremely rough or if it is don't have a porosity, then you can do it on any material. Penetrant testing can be performed on magnetic and non-magnetic materials but does not work well on porous materials. It means you can use it if material is magnetic or non-magnetic, but as I told you, you cannot use it on porous materials. There are 6 steps of penetrance testing. There are 6 steps of dye penetrant testing. The first step is to pre-clean. We have to clean the surface before applying the dye. The second step is penetrant application. We apply the penetrant. Excess penetrant removal. We will remove excess penetrant. Developer application. We will apply developer, and after applying the developer, we will inspect it, evaluate it, and again pre-clean all the things whichever we apply it, and we will use product again. Basic processing steps of a liquid penetrance inspection. The first is surface preparation. How we prepare the surface. So one of the most critical steps of a liquid penetrance inspection is the surface preparation. The surface must be free from oil, grease, water or other contaminants that may prevent penetrant from entering flows. We must clean the surface. The sample may also require etching if mechanical operations such as machining, sanding, grit blasting have been performed. If there is some operation performed, then it may be possible that there will be some scratches also. So we have to do etching by using some etching agent, so it will be like clean. These and other mechanical operations can smear metal over the flow opening and prevent the penetrant from entering. If there is a impurities present there, then what will happen? It will block the penetrant by entering the voids, and the operation will be failed. The second thing, after the cleaning all the surface, you have to apply the penetrant. So once the surface has been thoroughly cleaned and dried, the penetrant material is applied to spraying, brushing or immersing the part in a penetrant bath. You can see in the figure that this is a solid, this is your product, and you are applying liquid here. Like this is a penetrant, we will apply the penetrant. After applying the penetrant, you have to wait for some time. So the penetrant is left on the surface for a sufficient time to allow as much penetrant as possible to be drawn from a sip into a defect. We have to leave it for some time. Penetrant dwell time is the total time that the penetrant is in contact with the part surface. Dwell time, what is you will see the dwell time many times. So dwell time is the ideal time where penetrant will be in contact with the part surface. So how much time? Dwell times are usually recommended by the penetrant producers or required by the specification being followed. Which type of penetrant you are using, they will suggest you that how much time it will require. The times vary depending on the application, penetrant material used, and the material, the form of the material being inspected, and the type of defect being inspected for. Minimum dwell time typically range from 5 to 60 minutes. 5 to 60 minutes is a minimum time. There is no harm in using a longer penetrant dwell time as long as the penetrant is not allowed to dry. If penetrant is not dry, you can wait for some time, but you make sure that before drying the penetrant, you have to remove the excess penetrant. The ideal dwell time is obtained determined by experimentation and may be very specific to a particular applications. Once dwell time completed, you will remove excess penetrant removal. So you will remove excess penetrant. This is the most delicate part of the inspection procedure because the excess penetrant must be removed from the surface of the sample while removing as little penetrant as possible from the defect. Depending on the penetrant system used, this step may involve cleaning with a solvent, direct rinsing with water, or first treating the part with an emulsifier and then rinsing them with water. It depends on the condition that what type of penetrant system we are using. You can see in the following diagram that after dwell we will remove the excess penetrant from the surface. So if you see the diagrams here, you can see that in first step what you did, you clean and dry component, then apply penetrant. You can see you have applied the penetrant, then remove excess penetrant has been removed here, then apply developer. You have applied developer is the product which will visualize the defect in your parts. So your visual inspection, you can see the defects here. So let me take an example of a boiler, and here we see that how it takes place. And so if you apply this technique to the boiler, then you will use 3 ingredients here. Whatever dye penetrant testing you do, you always use 3 things. First is cleaner or remover, second is penetrant, and third is developer. So now 3 liquids are used in this method: cleaner, penetrant, and developer. Okay, now this is a boiler, and at the first, the surface of the I want to know that is there any crack on the surface. So the first surface of the material to be tested is cleaned. We will clean it first. If it is clean, then liquid is we will use cleaner for clean. The second thing is that to the then a liquid with a high surface wetting characteristic is applied to the surface. It means like we are applying a penetrant here. We have applied the penetrant. After 5 to 10 minutes, the excess penetrant is removed from the surface. We will remove the excess penetrant after 5 or 10 minutes, and then another liquid is applied. Then we will again another liquid is applied, that is a developer, and we called it developer. And after applying the developer, you will see that you will seeing some cracks there. There are 2 lines, so you are seeing 2 cracks there. So after dye penetrant testing, there are 2 surface cracks are detected. So after applying the developer, you will see due to the capillary action, again the liquid which goes to the voids, it will come out and it will be like show you the where are the defects are there, where are the cracks are there. So this is how you will complete this dye penetrant testing. So what is the common use of this inspection test methods? It is one of the most widely used non-destructive evaluation methods. Its popularity can be attributed to 2 main factors. Why it is popular? Because it is a relative ease of use. We can easily use. It is less costly and it is flexible. It can be used to inspect almost any material provided that its surface is not extremely rough or porous. Materials that are commonly inspected using LPT includes the following: metals like aluminum, copper, steel, titanium, glass, many ceramic materials, rubber, plastic, etc. So alright, hope you got the idea about how this testing is done, what are the steps we follow in these techniques. In next lecture, we will talk about what are the advantages and disadvantages of liquid penetrant testing. Thank you.